Hello everyone. So today we'll be discussing about semiconductor devices. This is one of the most important topic for your competitive examination. Around 3 to 4 questions are definitely asked in NEET examination. If you see 2019 paper, there are around 4 questions from this chapter. That is nothing but directly you are getting 16 marks. And this is also an easy chapter, not that much complicated. Some basic mathematics is required. Here, this semiconductor is divided into three parts. Those are basic diodes, transistor, and logic gates. And you can expect each question from each of this topic. We'll start with logic gates. So, even in previous IIT examination, you will be able to see around 2 to 3 questions from this topic, even for IIT examination. So, let us first start with logic gate, then we'll move on to transistor, then on to basic diodes. Before studying about logic gates, let us understand what are the different types of signal. Generally, there are two types of signal. One is called as analog signal and other one is called as digital signal. The analog signals are those signals whose voltage or current changes with respect to time. Either it could be voltage or current. Whose voltage or current changes with respect to time. These are continuous signal. These are continuous signal. Similarly, digital signals can have only two discrete values. Either it can be high or it can be low. And these are discrete signal, not continuous. Suppose this is voltage or current. Either it can have low value or it can have high value, or it can have low value or it can have high value. So generally, digital signals are represented by binary numbers that is 0 or 1. This low signal is represented by 0 and this high signal is represented by 1. 0, 1. And the branch of electronics which deals with digital signal is called as digital electronics. So the electronics which deals with this type of digital signals are called as digital electronics. Now where we will be using these digital signals? Now we'll be using these digital signals in performing logical operations. Logical operations. What are logical operations? Logical operations are nothing but some mathematical operations such as addition, subtraction, multiplication. So for this type of logical operations, we require some logic gates. We require some logic gates. So let us now study about what are logic gates. So I have already discussed logic gates are nothing but the building blocks of digital electronics which processes the digital signals in a specified manner. And further, what is a gate? A gate is a digital circuit. A gate is a digital circuit which follows a particular logical relation. Either this could be this logical relation could be a, for doing multiplication or for addition, or it could be subtraction, division. It can be anything. For performing this logical relation, we require a digital circuit which is obtained by using a gate. That is the name we got logic gates. See, I have given here 5 logic gates. Actually, generally there are 3 logic gates only. They are, first one is AND logic gate, second one is OR logic gate, and third one is NOT logic gate. And remaining two are what? Fourth one is NAND logic gate. See, NAND logic gate is nothing but combination of AND logic gate and NOT logic gate. Similarly, we are having one more gate that is called as NOR logic gate. So this you may understand that this is the combination of OR gate plus NOT gate. These two gates are called as universal gate. Universal gates. Why these are called as universal gates means we can form remaining 3 logic gates using these 2 logic gates. So we'll see that in upcoming classes. So now let us understand in depth or the functioning of logic gates individually. Now coming to first logic gate, we are having AND logic gate. See here, whenever you are when in English when you will be using AND, this and that means you are combining two things. So here AND logic gate is used for mathematical multiplication logical operation. Means it is used for multiplication here. So here AND is used whenever we are using whenever we are using AND gate, it represents multiplication. Here, as I said, logic gates or digital signals can take only two values. Either it could be low or the signal could be high. Whenever it is low, we'll be taking 0. Whenever it is high, we'll be taking it as 1. You have to remember this point. Now let us see the symbol for this AND logic gate. See, in AND we are having D. So the symbol for AND logic gate will be something like D. And it can have two or more inputs. These are inputs. This is input A, this is input B. Means we are giving some input signal. But it can only have one output. That is, I am representing it with Y. And see, this is multiplication. I said that AND is used for multiplication. So I can write output as A dot B. Now we are seeing its mathematical operation. As I said, it can either take value 0 or 1. Suppose initially I have given A is equals to 0, input I have given A is equals to 0, B is equals to 0. Then what will happen? Let us see the output of this mathematical operation. We know that Y is equals to what? A dot B. So what will be that? 0 dot 0 will be equals to 0. So here see first one, whenever I have given input 0, other input as a 0, what I will be getting? I will be getting output is also 0. So let us move to the second one. So see here, what is the input I have given for A? It is 0. What is the input I have given for B? It is 1. Now what will be the output? I know that Y is equals to A dot B. That is nothing but 0 dot 1. So what will be the output? The output will be 0. Similarly, for third mathematical operation, again I am taking that logic gate. I am applying the input here 1 because here A is given as 1 and B is given as 0. So again what will be the output? A dot B, that is nothing but 1 dot 0 will be equals to 0. Finally, let us see the last thing. When both the inputs are 1, when both the inputs are 1, here I have given the input 1, here also I have given the input 1. What will happen to the output? I can write output as Y is equals to A dot B, that is nothing but 1 dot 1 is equals to 1. I hope you understood this logical operation. You are supposed to remember this thing, this truth. This is called as truth table. You have supposed to, these are inputs, these both the things are inputs, and this is output. So the thing you have to remember in AND logic gate operation is, when, important thing, when both the inputs, when both the inputs are 1, then output will be 1. Only if both the inputs are 1, then the output will be 1. Otherwise, it will be 0. So this was regarding AND operation. So OR operation I will not be explaining in this step. By the seeing the diagram or truth table, you can understand that. OR means see here. Acha, see this one. This is AND logic gate represented using diode. Using diode. See, for AND logic gate, the diode symbol is in this direction. In this direction. Just you have to remember this. They may ask a direct question: which of the following symbol represents AND logic gate in terms of diode? So it's better to remember this thing. Now let us come for OR. This again, this is also a mathematical operation. I hope you will be able to get an idea as we have taken AND. I said that this and that means we are combining both the things. We have taken as multiplication. Now what about or this or this? You can take this thing or that thing. Means here we are performing addition operation. Addition operation. So the symbol for OR logic gate is something like leaf. There will be a leaf, no? It will be something like leaf. Again, it can have two or more inputs, but it can have only one output. I am representing input with A and B and output with Y. As this is used for addition, I can write output as A plus B. Now you can see the logical operation here. Here this is input, these are inputs, and this is output. So see here, initially if I have given 0 A and 0 B, now see what will happen whenever I have given inputs. This diagram you should remember. These diagrams are important. If you see previous year NEET question, directly they will be asking this, giving the diagram, and they will be asking which logic gate it is. So see here, first operation. I am giving A as 0, B as 0. What is the output? I know that for OR gate, output is A plus B. That is nothing but 0 plus 0. So what will be the answer? It will be 0. If I am taking, just a second. Okay. If I am taking input as A as 0 and input B as 1, if I consider now it as 0 and other input as 1, now what will be the output? It will become 0 plus 1. So what output I will be getting? I will be getting as 1. Similarly, whenever I am giving input A1 and B0, if you add both of them 1 plus 0, what you will be getting? You will be getting 1. Similarly, again I am giving input C here. Here one thing is there for noting down. This is input 1. I am taking the fourth one. This is also input 1. Now, what will be the output here? Well, you can take, if you think that 1 plus 1 will be 2, no, this is wrong. Because this is binary addition. You can either you can have value as 0 or you can have value as 1. There won't be any 2, 3 values. So what will happen to the other value? The other value will be carried on. मतलब क्या इसका और एक जो 1 आता है यहाँ से, they will consider the output as 1. The other value will be taken as carry for the next input. यहाँ से actually 1 आता और एक 1 कहाँ जाता सर बोलता हूँ, ये दूसरी जगह carry हो जाता. This value will be carried on. So always remember, in case of logic gates or binary addition, whenever there is a value 1 plus 1, because it can take only zeros and 1. Whenever there is a value of 1 plus 1, it will be 1 only and the other one will be carried on. Carry on बोलते हैं, carry on. You should not write 1 plus 1 as 2 because it is not there in binary addition. I hope you understood this OR logic gate. So final conclusion what I can write, in case of OR gate, when any one of the input is 1, when any one of the input is 1, then what will happen? Then output will also be 1. Then output will also be. So this is the statement you have to remember. In case of AND gate, what happened? When both the inputs were 1, the output was 1. Whereas in case of OR gate, what is the condition? If any one of the input is 1, then the output will also be 1. Now let us again, I think you will be having some diode symbol. Here you can see that two diodes are in this direction. This is again direct question. If you remember this diagram, it will be very helpful for competitive examination. Now let us move to the third logic gate, that is NOT gate. NOT gate is called as inverter. Inverter means it inverts the thing. You have to remember this diagram, very easy diagram. It will have only one input. It has only one input, a triangular diagram with a bubble in front of it. Everyone remember this thing. It has only one input with a triangle and a bubble at the end of the triangle, and it will be having only one output. If input is given as A, this is inverter, then output will become A bar. Means whatever input you are giving, the output will be inverse of that. Suppose I am giving input 1. What will be the output? Output will be 0. If I am giving input 0, what will be the output? It will be 1. It inverts the thing. Just like an inverter, it will invert the thing. But you have to remember that it has only one input and one output. I hope everyone understood this three basic logic gates. Now let us move on to the other two logic gates, which are combination of AND gate and NOT gate, OR gate and NOT gate. So see here, the next logic gate is NAND gate. It is combination of, ये क्या है? This is combination of AND gate and NOT gate. Let us draw its logical symbol. इसका logical symbol कैसा रहता है देखिए. What was the symbol for AND gate? I said that AND gate will be having D symbol. This is the symbol for AND gate, D symbol. There are two inputs and one output. Now to this AND gate, a NOT gate is added. What is the symbol for NOT gate? I know that the symbol for NOT gate is a triangle with a bubble. So see here, what will be the output here for AND gate? Output for AND gate will be A dot B. Now I said the what is the work of NOT gate? What is the work of NOT gate? NOT gate inverts the thing. It works as inverter. So here the output will be Y is equals to A dot B bar. I hope you are getting this. Y is equals to A dot B bar. Now let us apply the logical operation. What will happen? See here. Whenever A is 0, B is 0, what was the condition for AND gate? Condition for AND gate was when both the inputs are 1, when both the inputs are 1, output will be 1. Now, what inverter will do? Inverter will invert the statement. What it will say? What inverter will? It will say that when, or otherwise, let us do this thing. So what was the final conclusion we got from the final result we got from the logic gate input? We got, suppose am writing here, A, B are inputs and Y is equals to A dot B. Whenever input A was 0, input B was 0, I was getting the final answer as 0. Whenever input A was 0, input B was 1, again I was getting the final answer as 0. Whenever the input A was 1, input B was 0, again I was getting the final answer 0. But whenever both the inputs were 1, I was getting the answer as 1. This was the condition for AND gate. This was the condition for AND gate. Now, we are inverting this because now this gate is which gate? NAND gate. Means we have applied a NOT symbol. It will invert the result. Wherever it is 0, it will make it 1. Wherever it is 0, it will make it 1. Wherever it is 0, it will make it 1. Wherever it is 1, it will make it 0. See here, you can see this. So you are supposed to remember all these truth tables. You are supposed to remember all these truth tables. These are very much important. If you don't remember the truth table, you won't be able to solve the problem. And these are very easy. These are not some rocket science. These are very easy. So I hope you understood this logical operation. If you are remembering three basic logic gates that are nothing but AND gate, OR gate, and NOT gate, other logic gates you can derive by yourself. Just you have to invert the things. For AND gate, what is the output? I will be getting output for AND gate as 0, 0, 1. So NAND gate, what it will become? It will become 1, 1, 1, 0. It inverts the thing. I hope you understood this. So let us move on to the next gate. So next gate is NOR gate. I hope you will tell me NOR gate is nothing but combination of OR gate plus NOT gate. What is the symbol for OR gate? Symbol for OR gate is nothing but a leaf-like structure. A leaf-like structure. It has two or more inputs. What will be the output here? Y is equals to A plus B. To this OR gate, what we have attached? We have attached a NOT gate, a triangle with a bubble. What does this NOT gate does? Inverts it inverts the things. So I can write this thing as Y is equals to A plus B bar. So if you remember the logical operation or mathematical operation for OR gate, it has two inputs, A and B, and a output Y is equals to A plus B. What are the inputs? I can write input 0, 0, 0, 1, 1, 0, 1, 1. So what you will be getting if you add 0 and 0, it will be 0. 0 plus 1 will be 1. 1 plus 0 will be 1. 1 plus 1 will be 1, not 2. 1 will be carried on. Now, if you add a NOT gate, it will invert the thing. What will be that inverter? Y is equals to A plus B bar. Whatever answer you are getting, it will invert the thing. If the answer is 0, it will make it as 1. If the answer is 1, it will make it as 0. If the answer is 1, it will make it as 0. 0. If the answer is 1, it will make it as 0. I hope you understood this topic. This five logic gates. Actually, there are only three logic gates. Other two logic gates are combination of the remaining logic gates. So if the output for OR gate is A plus B is equals to 0, 1, 1, 1. For NOR gate, this is OR gate. For NOR gate, it will become 1, 0, 0, 0. So please study these five topics means along with truth tables. In the next class, we'll be solving the problems from this topic. You'll be solving the problems from this topic, including previous year paper. You can easily get 4 marks for NEET examination, and you can expect two questions from this topic only, two question or one question from this topic in JEE mains. This is one of